So 1.1, if we look at 1.1, 1.1 is on what? What's the concept? Lines. Where did you learn about lines? Secondary math 1, 2, or 3? 1. Yeah, the big idea in secondary math 1, my voice is cracking. The big idea in secondary math 1 was linear and exponential functions. Those were the really big ideas. So we are going to be doing, and for 1.1, the big idea is lines. Lines. What are the different equations you can use to represent a line? Let's say that we have some line like this. What are the different ways of writing an equation for this line? All right, y equals mx plus b. That would be one way. Equals mx plus b. This is called slope-intercept form. This is called slope-intercept form. That's one way we can do it. What does the m stand for? Yeah, I like to think of it as the move, but it is our slope, like you said. It's our slope. And how is slope defined? Yeah, it's defined as rise over run. That is our move. Our move is how much do we rise and how much do we run to get to another lattice point. These are called lattice points. A lattice point is a point that it's on the graph. It's a specific point on the graph that crosses one of those X marks on the grid. This is called a grid. This is the graph. Does everybody recognize the difference? The grid versus the graph? The grid goes in all directions to infinity. The graph is a set of solutions, infinite set of solutions that is represented by the equation. Graph versus grid. I don't know if you guys are comfortable with those two differences, distinctions. All right, so we have this rise over run. What, in this case, what is my rise over run? What's my rise? Yeah, about 2, and my run? 1. To get from one lattice point, like here, to the next lattice point here, we have to go up 2, and we have to run 1. So we have a rise over run, up 2 over 1. Our slope, in this case, is 2. What's the B? Yeah, that is our y-intercept. I like to call it our begin. It starts with a B, it's our begin. So we can think of this as, say, time. And so at time 0, our begin in this case is 1. So our B is 1. So our equation then for slope-intercept form for this line is what? Y equals 2x plus 1. Yep, this is an equation. How many solutions does this equation have? Infinite. Yep, I can put any value in for x and it'll give me some value for y. There are infinite solutions. All right, so we have slope-intercept form. What is another acceptable equation for a line? Standard form. Standard form is definitely another method, another way, another equation. So we have standard form. If I'm going too fast, let me know. Always hated when I'm about to write something down and then, oh, the teacher moved on. No. So just tell me to go back if I'm going too fast. So standard form. And standard form looks like this. A times x plus b times y equals c. Now, I had yesterday in my calculus class, one of my students said, well, that's standard form, but it's not good for anything. And I have to admit that my preference is probably slope-intercept form. I'll have to admit that that's probably my preference because it tells us our slope and it tells us our begin or our y-intercept. It tells us a lot of information, and because it's a line, we just draw the line really quick. It seems really straightforward. But I'm going to suggest that there might be a benefit if we decide to graph. Let's say we have something like this. We have 2x plus 3y equals 6. And I want to graph this. Let's graph by intercepts, by x and y intercepts. How do you find an x-intercept? Yes? Yeah, y has to be 0. Y has to be 0. If y is 0, what happens to this piece here? It's gone. Yeah, it's gone. So our x-intercept is what? That's 3. Yeah, we just divide both sides by 2 and we get 3. So if we have in standard form, we could easily find the solutions by x-intercept. So again, an x-intercept, by definition, an x-intercept, how does that make sense if y isn't 0, right? This is what, 1, 2, 3, 4, 5. So this is 5, 0. How could you have an x-intercept where y isn't 0, right? That's just silly. Y has to be 0. Y has to be 0. All right, we didn't find that y was that our x-intercept was 5 though. We found that it had to be what? If this is 0, this is gone. It has to be what? It has to be 3. So we're going to put a little mark here. This is one of the solutions, one of the infinite solutions that we have. Our x-intercept is 3. How do you find a y-intercept? X has to be 0. Let's make that 0. Does that make sense? If I have a line that goes through the y-intercept, does that make sense that x has to be 0? Does that make sense or not? It has to be. It has to be. All right. So if I make x 0, then this is gone, meaning that my y-intercept is what? It has to be 2. Yeah, divide by both sides by 3 and I get 2. Do you feel like I'm skipping steps? Does anybody feel confused? I don't want to skip any steps. I know that math is hard already. I'm skipping steps because I'm not writing this out, right? I'm not saying make x equal to 0 for a y-intercept. And if you want me to do that, I will. But if you don't need me to do it, then I won't. Right? I'm not doing this, but I could if it helps. And then this goes away. We divide by 3 to both sides, so we get y equals 2. In this case, we get y equals 2. So I don't want to skip any steps, but if that makes more sense, I will. All right, so that means that we have our other intercept is right here. Well, how does that help me find a line? How do 2 points help me find the linear equation or the linear graph? Do we need to find the slope? I'm just looking for the graph. I want to find the graph. Yeah, we know it's linear, so it has to be a line. Because it's linear, it has to be a line. So this is the only choice, right? That's the only choice to go through those 2 points. I don't know if I'm being overly perfect there, but there you go. Yeah, there's only one choice going through those points. So anyway, just consider that there might be some benefits to standard form by graphing the intercepts. All right, so we have standard form. We have slope-intercept form. Anyone know what the other one is? Nobody? Let's go back. Let's remember what we did last year with quadratics. Let's zoom in a little closer. How many acceptable equations are there for quadratics? Is there a standard form? Isn't standard form like this? Y equals a times x squared plus b times x plus c. And then we can find, in this case, we can find our x-intercepts if y is 0. And then we use our negative b plus or minus the square root of b squared all over. Yep. So we take these coefficients and we plug them into our quadratic formula, and it gives us the x-intercepts. If this was just an equation, I would solve so that I get 0 on this side and then use the quadratic formula to find the solutions to the equation. All right, so we have what's called standard form. There are two other ways, acceptable ways to write a quadratic. What are they? Okay, factored form, where you have y equals x plus, well, let's do minus n and x minus m. What's the benefit of factored form? Vertex is actually a third one. Our third one. What's the benefit of factored form? Yep. In this case, what are my x-intercepts? Yep, n and m. So we have some n and m. I go through those points. What's the benefit? Oh, so vertex form. Vertex form looks like this, where we have y equals x. Let's do x minus h squared plus k, where hk is what? Is the vertex. Yep. There are three acceptable ways to write a quadratic in standard form, in factored form, and vertex form. So it shouldn't be a big surprise that there are three different acceptable ways to write a linear. We're missing one. What is it? We have slope-intercept. We have standard form. The other one starts with a P. Point slope form. Point slope form is the third one. Don't want to go too fast if you're still writing. Always hated it when the teacher just rushed on. All right. Please watch the Zoom meeting. Okay. All right, awesome. Oh, so it was a good idea that Mr. Hall is recording these on Zoom. Awesome, cool. What's that? What did you say? Nothing. Thank you. You're welcome. All right, are we good? Okay, so the other one, the third linear is, what was it? Point slope form. Point slope form. Do you remember what point slope form looks like? Start out y minus that's just awful. Y minus y subset 1 equals m times x minus x subset 1. Well, Mr. Hall, that looks awful. How do you remember that? Why is it important? Well, you just ask 2 questions, or I should say I asked 2 questions. And well, what if this is point slope form, right? What if I divide both sides by this x minus x subset 1? What happens if we divide both sides by x minus x subset 1? Yeah, we get slope. We get our slope equation. If I divide both sides by x minus x subset 1, what I get is m equals y minus y subset 1 over x minus x subset 1. What's the difference if we look at a graph and I have some point right here and another point right here? What's if I say that this is some y value here, and we'll say that's y subset 1, and then we have some other y value here. If I take y minus the other y, doesn't that give us our rise? If we subtract those, doesn't that give us a rise? And what if I subtract the x values, this x here and this other x over here? What does that give us? Our run. Yeah. So this is our slope. That is our slope equation. Why? So this point slope form, it's really just our slope equation. And what's the benefit of having point slope? Well, I would say if I have 2 points, right? Find the equation in point slope find the equation in point slope of the line through points, I don't know, 2, -6, and -4, 8. What's point slope? Y minus y subset 1 equals times. Nice. Yep. So what do? I want to use point slope form, and I want to write an equation that goes through those 2 points. Yeah, so I plug in numbers. What numbers should I plug in and where? All right, so this is a y and this is a y, right? So you're saying this is y subset 1. So you said 8 minus -6, okay? -4 is your x, and this is your x subset 1 minus 2. Yeah, yep. Now what? Should we figure this out first? Because that would be sort of like combining like terms, right? So what is this? All right, so a negative and a negative is a, so I have 8 plus 6, which is 14. You guys are right. All right, and then I have 14 equals m times what? -6. Now what? Sorry? Divided by -6, so that's going to give me 14, -14, 6, right? Equals m. Can that be simplified? -7/3. Yep. So if I'm trying to write an equation that's in point slope form, then Where do I go from here? Which of these should I use in my equation? It doesn't matter. It doesn't matter which one. They're both correct. I can write y minus negative would be a positive, right? 6 equals negative 7/3 times x minus what? Yeah, that's completely acceptable. Or I could write y minus 8 equals negative 7/3 times what? X plus 4, yeah. Both of these represent our equation. Or our graph that go through these 2 points. They are both acceptable. Now the problem is Mr. Hall has already done all the problems and I chose which one of the points to use. And so that's something you'll just have to figure out which one matches the choice, the answer. But just be aware that either of these are a choice. In fact, because this represents a line and a line represents infinite solutions, then there are literally infinite point slope forms that will make this work. What if I wanted to rewrite this from point slope form? What if I wanted to rewrite this in slope intercept form? How do you rewrite in slope intercept form? How do we do that? How do we rewrite that in? Right now, this is what? What kind of equation is this? Point slope. How do I rewrite point slope form in slope intercept form? Slope intercept form is what form? Y equals mx plus b. I need to somehow get y equals mx plus b, have it look like this. How do I do it? Okay, let's distribute. So I have y equals 8. Sorry, y minus 8 equals negative 7x over 3. And then this is the same thing as over 1, 4 over 1, right? So I'll multiply, when we multiply fractions, we multiply the numerators to get a numerator answer, 28. We multiply the denominators to get a denominator answer. All right, now what? Add 8 to both sides. So that's going to give me y equals negative 7x thirds minus 28 thirds plus 8. Are we done? Do what? Yeah, somehow we have to put these together. These are like terms, right? They don't have an x. These are not like terms, right? This has an x, so it's not a like term. So somehow I have to put these together. How do we put these together? Yeah, we have to have a common denominator. 8 right now is 8 over what? 1. So what's our common denominator? 3. So I multiply by what? We're not going to multiply by 3 because if I multiply by 3, I've just changed the quantity. But we're really multiplying. I know what you mean. I know what you mean. I just want to make sure that we're all on the same page. We're not multiplying by 3. We're multiplying by 1. What's really cool about multiplying by 1 is it doesn't change the quantity. Anytime, if I have 1/2 times 1, it's 1/2. If I have 8 times 1, it's 8. If I have 100 times 1, it's 100. That's the cool thing about multiplying by 1 is it doesn't change the quantity. So I'm not multiplying by 3, I'm multiplying by what? 3 over 3. So I'm multiplying by 1 in the form of 3 over 3. So that gives me Yeah, and I know what you meant. I just want to make sure that we're all on the same page, that we understand why that works, why we can do that, why we're not violating any rules of math. So I have y equals negative 7x thirds. This is a 3. And then minus 28 thirds plus what? 24 thirds. Okay, now what? What if we put these together, what do we get? Negative 4 thirds. Yep, we get negative 4 thirds. So I have y equals negative 7x over 3 minus 4 thirds. What's my m? What's my b? Negative 4 thirds. Yep. So we're done. We found it. So we went from point slope form. We found point slope form for, I don't know, I guess we have 2 points. We found point slope form. And then we converted point slope form to slope intercept form. Any idea where I'm going to take us next? What do you think I want you to convert this into? So yeah, we're going to do standard form. Am I going too fast? Is everybody good? Okay. Rewrite in standard form. Rewrite in standard form. Well, what do I do? Remember, a standard form is this form of a times x plus b times y equals some c value, right? How do I rewrite this in standard form? Would you agree that a plus b over c equals a over c plus b over c? Is that true? Yes? Okay. Can we do the same thing with this? Take that and move back to this. What does that give us? If this is true, and it is, how do I move back to this? That gives us what? Y equals? Yeah. Now what? How do I get rid of this? Yeah, let's multiply by 3. Let's multiply by 3 to both sides. This goes away, leaving me with 3y equals negative 7x minus 4. Now what? Yeah, just add 7x to both sides, and that's going to give me 7x plus 3y equals negative 4. Are we done? Yeah. That's of the form of ax plus by equals c. So we're done. That is the answer. Is everybody good? And I want to talk about some notation now. You're going to see, so this is what we're talking about. Okay, go closer. We're going to be talking about some notation. So I'm going to write this. Have you seen it before? What does it mean? Can you say anything about this? Yeah, this is delta y over delta x. This is delta over delta x. What alphabet does delta come from? Yeah, it's the Greek. It's the Greek alphabet. Is it a capital or a lowercase letter? Not that it matters. And actually, I don't know. I think it's capital. I think it's capital, but I'm about to find out. Greek letter delta. Ah, there you go. All right. Yeah, so there's a capital delta and a lowercase delta. What does it, so we can read it, right? This says delta y over delta x, but what does it mean? It means change of y over change of x. This means change of y over change in x. This means change in y. Let's do change in y. Change in y over the change of x. And I would argue that change, if it's changing, if I'm looking at something, let's go back to this point right here and this point here. This is some x, y, and this is some other x subset 1, y subset 1. And the change, when we change from this y here to this y here, what's that? The change is what? Isn't that just our rise? Isn't that subtraction? Isn't this the same thing then, as more or less? Isn't that the same thing as our y minus y subset 1 over x minus x subset 1? It's just a notation. It just means the change. We're literally talking about the change. What kind of change is taking place when we go from one y to the next y? What does, is everybody good? Mr. Hall, why do we need to know all of this? This is baby stuff. This is from secondary math 1. Why do we have to learn it all over again? I've already learned it. It's because of the direction we're going in calculus. In calculus, probably the most important pinnacle part of calculus, where all of the calculus comes from. And consider trigonometry. Trigonometry is a huge branch of math, but all of trigonometry comes from is the similarity of triangles, right? If your angle is the same for one small triangle versus another triangle, then from the perspective of that angle, your opposite over hypotenuse is going to be the same for both. Your adjacent over hypotenuse will be the same for both. Your opposite over adjacent is going to be the same for both. My point is that just this little piece of information about SOHCAHTOA, we get this huge branch of math. Here, there's the pinnacle concept in calculus is this idea where here I have some curve here of finding the instantaneous rate of change. Here's a point right here, some x and y value. I want to find the instantaneous rate of change. What is that? What's the slope of what is called the tangent line? Tangent, the tangent. And the problem with using our equation over here, what's the problem using that equation? Well, if I have the same point, then I have y minus y over x minus x, which would give me what? 0 over 0. Is that even acceptable? Is this acceptable? Why not? Why is this not acceptable math? It's not going to be flat. You cannot divide by 0 because of this little piece of information right here. This is illegal. We have violated a rule of math. So how do we find this instantaneous rate of change? This is where calculus, this is called a derivative, the instantaneous rate of change. Instantaneous rate of change. This is where all of calculus comes from. This massive branch of mathematics that comes from the idea of trying to find an instantaneous rate of change. Why is that important? Well, it's important every day. Every day when you're driving to work or driving to school and you look down at your speedometer, you're looking at the instantaneous rate of change, right? You're looking at what the speed is exactly at that moment. That the instantaneous rate of change is your velocity at that specific point of time.
If it pertains to the tangent line, how does it determine what the angle is?
So I didn't mean to connect trigonometry to that. So I was just trying to say that this idea of SOHCAHTOA, right?
Not angle. I suppose I meant like, how do you determine the slope?
How do you determine the slope? That's a good question, and that is in chapter 2. Okay, so chapter 1 is just a review, but we're reviewing important stuff that you're going to need to know in the future, because I might say, what is the equation for the tangent line? Well, we're going to use a derivative to calculate the slope here, which you'll learn in the second chapter. But to find the rest of it, you're going to have to use one of those linear equations, like y equals mx plus b. This is going to be your derivative. This is the calculus part. But how do you find the rest? Secondary math 1. What you're learning right now is critical for success in calculus. You have to know how to find an equation of a line. You have to know how to find an equation of a line. If this is the only one you know how to do, you're probably okay, but you better know how to do it well. How would I, let's go back to this equation over here. Let's go back to this one. Where's the 2 points? Okay, so I have 2 points. So instead of finding the slope-intercept form, we already found, point slope form. We already found the point slope, the slope-intercept, right? We solved for this and found it down here somewhere. Yeah, there it is. We already found it right here, right? Can we find it directly? Let's say the only thing you know is how to find a linear equation from a graph by using slope-intercept. Say we don't remember how to do this, or we don't remember standard form. That's okay. Is it possible to find, using this slope-intercept form, to find the equation that goes through these points directly? Is it possible? In fact, let me just grab this. Move over and up. So I don't want to do this by point slope form. We're going to directly calculate it using slope-intercept form. So we're going to use not this, but slope-intercept. Is it possible to do that directly? And if yes, how? We need to use y equals mx plus b. How do we do it?
Find the slope and then plug in the values to find the b.
Yeah, find the slope. What's the equation for slope? Isn't it y first? Isn't it? Rise is always the y values, right? So it's y minus y subset 1 over x minus x subset 1. So that would give me what? What's in the numerator? -6 minus 8, okay. And the denominator? 2 minus -4, okay. So that gives us -6 minus 8, which is? -14 over 6, which can be simplified to? -7/3, okay. Now, how do we find the b value? Which point? It doesn't matter. You're right. Which one do you want to plug in? First one. So the first one. So this is my x and this is my y. We're going to plug in -6 equals -7/3 times x, which is 2 plus b. Now what? -6 equals what? What is this? Yeah, that would be -14/3 plus b. Now what? Sorry? Add 14/3. Okay, so that gives me -6 plus 14/3 equals b. How do we put this together? This, oh, well, how do we put this together? Okay, so this is -6 over 1. So what are we multiplying by this to get a common denominator? What? So we're multiplying by 1, right? In the form of 3 over 3. And so that's going to give us negative what? Over 3 plus 14 over 3 equals b. And then -4/3. Was that the same b that we had before? You remember? So our answer then is going to be what? Y equals -7/3 x minus 4/3. Nice. That should be the exact same answer we had before. So in chapter 2, actually, you're going to see this in chapter 3. You're going to actually see this all the way through. You're going to see in your calculus class over and over again, where you have to find the line, the equation of the tangent line. This part here is the calculus. This will be your instantaneous rate of change. That's something you haven't learned yet, but the rest of the math is the same. Now, there's another important thing that we haven't talked about. I want to find the equation of the line that is parallel to y equals, I don't know, 3x plus 4 and goes through to -7. Let's do slope-intercept. How do I do that? Find an equation of the line that is parallel to this equation. Why does this matter? Why is that important?
Well, because it's gonna have the same slope, so if we plug that into an equation that already has the same slope.
Yeah, so we already know that they gave us most of the information here. We know right now that m is 3. Does that make sense that if we have two parallel lines, that the slope, if we don't rise and then run exactly the same for both, that eventually they will intersect? Does that make sense that the rise and run have to be exactly the same? Otherwise, your lines are going to intersect. So that means that this is really important. If I know they're parallel, it means that my slope is the same. I already know what my m is. My m is 3. Okay, so how does that help me? So I have y equals mx plus b. Where do I go from here? Okay.
Use the point that
Yeah, that tells us our x and our y value, right? So that gives us 2 and -7. Okay, now what? What do we do now? Okay, 3 times 2, which is? Okay. So I have, okay, is my math weird? Is that why you weren't answering? Because I had a weird, I wrote equals instead. Okay. Yeah, sorry about that. Does it make more sense now? Okay, so this gives me -7 equals 6 plus b. So what does b equal? -13. So what's my equation? 3x minus 13. Yeah, there you go. That's parallel to this equation and goes to this point. Super important. But because we're going to be doing the same thing, but with calculus. So I use the word parallel. What if I'd say the same thing? In fact, I'm just going to copy the whole thing. I'm going to copy the whole thing. And instead of using the word parallel, any guesses what I'm going to say? Yeah, perpendicular. In fact, I actually don't know if somebody wants to look it up, they're welcome to, but in calculus, instead of using the word perpendicular, they use the word normal. They'll say find the normal. And what they mean when they say find the normal is they want you to find the perpendicular line to the tangent line. So they'll say find the normal to the tangent line. If you see the word normal, and it's funny because we use the word normal, but we don't use the word abnormal. If I say find the normal, so here's my curve, right? So this is future. This is something we haven't learned yet. So if I have some curve like here, and this is my tangent line here, what makes it a tangent line? Why is this called a tangent line? Does anybody know? Why is this called a tangent line? Anybody know why this is a tangent line? This is a secant line. It's called secant. It's a secant line. This is a tangent line. What makes it a tangent line? Any guesses? What? I can't hear you. One intersection. So if that's true, then is this also a tangent line?
Well, then it'll eventually intersect with another point in the. Eventually.
What makes this a tangent line and not this a tangent line? It's only on the outside. In fact, the way that they define a tangent line in calculus, the way that they define a tangent line is it's 2 points that are infinitely close together. A tangent line goes through 2 points on a graph that are infinitely close to each other. So that forces this as a tangent line versus this as a tangent line. If I have a line like this, I'm only going through the graph one time. If I have 2 points that are infinitely close to each other, then it forces this is the only possibility. If you have a line on a curve that goes through 2 points that are infinitely close to each other, what's that called? If I have a line that touches a curve, and it hits the curve through 2 points that are infinitely close to each other, what's that line called? It's called a tangent line. We call it a tangent line. That's a very important word in calculus, because that tangent line will tell me the instantaneous rate of change at that point. Right? Now I could change the tangent line. I could certainly change the tangent line. We can move it over here. If that's not yet a tangent line, I have to sort of manipulate it around like this. And now it's a tangent line, but now the tangent line is over here. It's telling me, the tangent line tells me the instantaneous rate of change. That's a huge idea in calculus, but it's not in chapter 1. Then why are you covering it? Why are you talking about it, Mr. All? It's not in chapter 1. Why are you talking about it? Because that's the direction we're going. That's a huge idea. All of these things, I don't want you to think that they're separated. It's all Mr. All just wants us to learn a bunch of stuff that we learned back in secondary math 1 today. We'll never see it again. No, you're going to, the whole point of using chapter 1 is covering not everything from secondary math 1, 2, and 3, but covering the important things that you need to build on when it comes to calculus. So make sure you understand these. Make sure you understand how to do this, so you'll understand how to do the next step. All right, so we're doing the same thing here, except what was I going to change parallel to? Perpendicular. And in calculus, instead of using the word perpendicular, they use this other weird word. What do they say? The normal. How is it normal if there's nothing that's abnormal? I don't know. That's something you can look up if you want. I don't know why it's called normal, but so what is, so find the equation of the line that is perpendicular. Just be aware, in calculus, we call it the normal. It's the line that is normal to the tangent line. It means it's perpendicular. Best of luck. Just watch the last, 15 minutes? Okay, cool. See you later. The normal. The normal to the perpendicular is the what do we change the slope to? The negative reciprocal. We have to change this, change slope to the negative reciprocal. What does reciprocal mean? I don't know if you call it opposite, because isn't the negative, if it's positive, then it's negative. Isn't it feels like that's sort of opposite. Actually, they're inverses. So we don't really use the word opposite very much in mathematics because it's ambiguous. It seems to have I guess you have to look at the context to determine what that meant as an opposite. But it's when you take a fraction and you flip it upside down. Reciprocal means the numerator becomes the denominator and the denominator becomes the numerator. You're flipping it upside down. So I don't know if you'd call that opposite, but we do call it the reciprocal. To use precise language, that's called the reciprocal. What is the reciprocal of 3? Yeah, because this is 3 over 1. And so if we flip that fraction upside down, that gives us 1/3. So the reciprocal is 1/3, but I don't want the reciprocal. I want the negative reciprocal. What's the negative reciprocal of 3? Negative 1/3. So this is my slope. That's my slope is negative 1/3. All right, now what? Yeah, let's plug it into our equation. We have y equals mx plus b. We know what our m is. Our m, is that too small? Is that, can you guys see that? Okay, so our m is negative 1/3. Now what? Yeah, plug in our this x and the y over here. Let's plug that in. So I have negative 7 equals negative 1/3, and my x is 2 plus b. All right. Okay. Are we stuck? What do we do here? Okay, simplify this. That gives us what? Yep, so I have negative 7 equals negative 2/3 plus b. Now what? Okay, so I have negative 7 plus 2/3 equals b. Okay, how did you do that?
You can multiply 7.
All right, so we're going to multiply that. So 7, negative 7 is the same thing as negative 7 over 1, right? And we're going to multiply by 1 in the form of 3 over 3. And so that's going to give us negative 21/3 plus 2/3 equals b. Now what? Negative 19/3. All right, so let's look at, so let's go back. I don't know if it's, if I zoom out, I'm just scared that it's hard to, for you to see with it all. It's so small now. But I want to make sure that you see everything. Now what? What's our equation then? Y equals what? Let's use our slope-intercept form. Yeah, that's our equation. That equation is perpendicular to this other equation, right? And it goes through this point. It does both. Right. Are you, anybody still copying? Okay. What's the equation for this blue line? What is it? Y equals 3. Can we use y? Can we use y equals mx plus b to get the same answer? What's m? If I put a marble here, what direction does the marble roll? It doesn't roll. Why not? We have a 0 slope. We have a rise to go from here to here. We don't rise at all. So a rise of 0 and a run of 3. So we have a 0 slope. We have a 0 slope here. So this m is 0. 0x plus b equals y. The b is what? Yeah, it's the y-intercept. That's 3. So I have y equals 0x plus 3. What's 0x? 0. So we still get this y equals 3. In other words, y is always 3. Now this could, under the context, this could just say that the variable y equals 3. But under a different context, y equals 3 represents an equation, a horizontal line. So it means two different things. It can mean that this variable equals 3, or it can mean there's an equation that is y equals 3. That should not be too strange, because in language arts, you have the same thing. In language arts, they might say, you know, they have something like, you know, what does this say? Yeah, tier or tear. It depends on the context, right? It depends on the context what it says. The same thing here. It depends on the context what that means, y equals 3. In this case, it is a line. It is an equation of a line, y equals 3. What if I have this 1, 2, 3, 4, 5? What if I have this other, let's make it purple. What if I have this other line like this? X equals, sorry? X equals 5, yeah. And it's hard to explain that it's x equals 5 using this equation because the slope is undefined, right? The slope is undefined because, well, try to use the vertical line test. I have a 0 denominator. Yep. So I have an undefined. So I can't really use this, but I think a good explanation for why it's x equals 5. Well, let's look at the y equals 3. This point here is 2, 3. This point here is 3, 3. This point here is 4, 3. This point here is 5, 3. Y is always 3. Y is always 3. Now for this other line, the purple line, x is always 5. This point here, right here, is 5, 0. This point here is 5, negative 1. This point here is 5, comma, negative 2. X is always 5. X is always 5. What's that?
So even when the secondary change is the same, that would indicate the same thing?
The secondary?
Yes.
I'm not sure what you mean by the secondary.
If we were to, you're saying that we notice that all these points are the same number, and you would, so ideally we're looking at a table.
Yeah, you're definitely looking at it. Yeah, that makes sense. Yeah. So if I did a table right here, you would see here's X and Y. I have, here's my table 5, 0, 5, negative 1, 5, negative 2. We're seeing that it's always the same over there. So yeah, X is always 5 in this case. So that's our equation, X is 5. I just don't want you to get mixed up with what a vertical line is versus a horizontal line. A vertical line, and here's the confusion. What is the horizontal axis? X. What is a horizontal equation? Y. Y equals 3 in this case, right? What is the vertical axis? Y. What is a vertical equation? X equals something, yeah. So I just don't want you to get confused because of that. Just be aware. So I was trying to explain it the best I could of, why they're the way they are. Maybe some of you, it already makes sense, but I know that some of you, I know for me, it was confusing. Why is it the opposite? It seems like it's the opposite. But anyway, I just want to make sure that I covered everything. What is delta? What does delta mean? It means the change. Make sure that we remember that. The 3 equations, you need to know those 3 equations. The 3 linear equations are what? Slope. Intercept form. What else? Standard form and point slope form. Good. If you have an equation that give you an equation and you have to find another equation that is parallel. Why is that helpful? Because the slope has to be the same. What if I tell you that the slopes have to be perpendicular? You have to have negative reciprocals. What is a reciprocal? What's flipped? The numerator and denominator have to be switched, and you have to make it negative. That's really, really important. In calculus, when I talk, you're not going to see perpendicular. You're going to see another word. What is that other word? Normal. I'm going to say, find the normal to this tangent line. That means the perpendicular line to the tangent line. You'll use calculus to find the slope, and then you find the negative reciprocal to it. That's how you're going to find the normal. You find using calculus that I have not taught you yet. You'll learn this in chapter 2. You'll find the slope to the tangent line, and then you'll take the negative reciprocal of it to get the normal.